Good morning everyone. I am Renu Sharma, Assistant Professor, Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to start with the next part of the subject, that is data communication network, and the topic of today's lecture is wireless LAN. So, these are the topics that I am going to cover in this lecture, that is IEEE 802.11 standard, then CSMA CA. So, before I will begin with this, I will start with what is wireless LAN. So, what is LAN? First thing is that what is LAN? LAN is nothing, it is a local area network. Local area network means a network that has been established in a office in a very small area, so that the proper transmission and reception of the data has been taken place, has been taken care of. So, that is the case for local area network. But in case of wireless, what do you mean by wireless? Wireless means there is no wired connection is there between the transmitter and receiver. It can be done without wire, but there is a range that is to be maintained between the transmitter and receiver. If somehow the receiver will going out of range of that particular setup, then the transmission and reception will not be quite well. So, there are different standards that has been given by IEEE, which is based on 802 standard and 802.11, 802.12, and there are different standards which are established by this IEEE. So, we are going to discuss one of the standard in this lecture, that is IEEE 802.11. Then after that we are going to see a topic, that is carrier sense multiple access collision avoidance. So, that is a case for multiple access technique, where more than one user are going to use a single common channel, and after the collision has taken place or before the collision, how it can be avoided. So, that is the case that we have to see in this lecture. So, what is IEEE 802.11 standard? It has defined the specifications for a wireless LAN called IEEE 802.11, which covers the physical and data link layer. So, what is this physical and data link layer? I am going to revise it. What is physical and data? If I am considering ISO OSI model, which is a very famous model, that is layered architecture, based on layer architecture. So, in this model there are basically 7 layers are described. Now, one of the layer is physical layer, then there is a data link layer. On these two layers, these are the first two layers. On these two layers you can see over here that this IEEE 802 standard lies. Then there will be a network layer, transport layer, session, presentation and application. So, these are the 7 layers that are being described with this by this ISO OSI model, and after this OSI model, these 7 layers are reduced to 5 layers in case of this TCP IP protocol. That is nothing, it is the transmission control protocol, internet protocol, which will going to reduce the number of layers required for the purpose of transmission. So, here this IEEE 802.11 standard will going to cover the physical and the data link layer. Now, these are some of the units. In the next diagram I am going to show you what is BSS. A BSS without an AP is called an ad hoc network. So, this is a kind of a network, and a BSS with an AP is known as an infrastructure network. So, these two networks we will discuss in the next slide. So, what is ad hoc and what is infrastructure? So, without it is ad hoc, and with AP it is known as the infrastructure. So, this is the basic diagram, that is the basic service set. BSS means that we have discussed that what is BSS, it is basic service set, and AP is the access point, as you can see over here. So, in this ad hoc network, this is BSS without an AP and this is BSS with an AP, which means an access point is there. So, as you can see that in this diagram there are different stations are connected, there are 4 stations are connected in this network, and in this case there are also 4 stations are connected, but there is an access point is there, that is denoted by an AP. So, this is basic service set BSS without an AP, and this is with an AP for the purpose of transmission. So, this is BSS. Now, next is the extended service set, that is denoted by ESS, extended service set. This is ESS, this is BSS, and this is denoted by access point. So, this is the distribution system which has been written over here. So, this is BSS, this is nothing, it is a BSS which is connected through this access point. So, as you can see that there are 3 computers are there which are connected through this access point, and in this network also there are 3 computers. So, you can see over here when there is a cell which has been created for this network, then this computer will lies in both the cells. So, what it is known as? It is known as the extended service set. Why it is known as extended? From this point it is BSS, it is connected through a distribution system, and then it is connected through a server or a gateway. So, whatever transmission is been possible, let us say from this BSS computer, this computer wants the transmission to this computer in another BSS, then it has to be done through this service access point, that is the server, and then it has been transmitted to this point. So, there is a security issue is there, and this is the extended service set, means larger number of devices are connected in this network. So, this is the server or the gateway is there, and this is the distribution system which is an intermediate which is going to connect these 3 or different BSS through this gateway system. So, this is the extended version of BSS. Now, next is the medium access layer control, medium access control layer, that is the MAC layer in 802.11 standard. So, you can see over here that as it is already mentioned in the first slide that IEEE 802.11 standard will going to connect to this physical layer and to this data link layer. So, basically 2 layers are being connected in this case, that is the physical layer and the data link layer. In this case you can see that a physical layer, it is divided into different spectrums, like this is frequency hopping spectrum FHSS. Next one is direct sequence spectrum, that is DSS. Now, next is this is using this infrared set of frequencies for the purpose of transmission and reception. This is again using DSS, that is the direct sequence spectrum. This is using optical fiber direct modulation OFDM technology, and this is using this DSS, that is direct sequence spectrum. Now, first I will tell you what is spectrum. Now, spectrum is a kind of technique for the purpose of encryption. Whenever there is a single message data is there, single user wants to transmit the data, let us say 1011 data has to be transmitted, this is modulo 2 addition, and there is a PN sequence which has been generated, and this is having larger number of bits as compared to this message bits. So, this is having 4 bits and this is having maybe 10 bits are there, maybe 15 bits are there. So, more than this, this PN sequence is generated. This is also known as a key. Why it is known as a key? Because whatever set of bits you are using over here, the same set of bits has to be transmitted at this point, means the same set of bits, the same PN sequence has to be used at the receiver side. So, that is the case of PN sequence. So, this is the message bit and this is the PN sequence, which is of higher length as compared to the message bit. So, modulo 2 addition will be performed over here and a coded information will be transmitted from the transmitter side. So, this operation is performed at the transmitter side. Now, same reverse operation has to be performed at the receiver side, where we have received this encoded data. That encoded data has to be modulo 2 added with this PN sequence. Now, the PN sequence which is used at the transmitter and receiver has to be same. In only in that condition the proper reception will be possible in that condition. So, these are the message bits and this is the PN sequence. So, this is physical layer. So, in this case, this is the case for direct sequence spectrum. So, there are basically 2 types of spectrum techniques are there. First one is DSS, another one is frequency hopping. In case of frequency hopping, the data will be will going to hop as per the name, it will going to hop from one frequency to another frequency. So, that is the case for FHSS. Now, this is the data link layer, this is MAC sublayer, this is LLC sublayer, logical control unit, that is LLC, and you can see that this is denoted by the distributed coordination function, that is denoted by DCF, and this is denoted by the PCF, that is a point coordination function. So, both these functions are required at the MAC sublayer. This is contention free service. Contention free service means there is no traffic or there is no problem of over accessing of the channel will be possible in that case. There is, this is contention free service which has been provided between these two layers, and this is the contention service means there is a problem of traffic which can taken which has to be taken care of. Then LLC sublayers is denoted by this one, that is the IEEE 802.1 standard. Now, next we will move to the next part of this lecture, that is CSMA CA. What do you mean by CSMA CA? Full form is Carrier Sense Multiple Access Collision Avoidance. There is another variation I have already discussed in my previous lecture, one of the previous lecture, that this is collision avoidance. Another variation is collision detection, that is CSMA CD. In that case, that is a part of Aloha only. In case of collision detection, there is no condition is there, collision will going to take place and it has to be avoided. So, it is avoided in that in this situation only, that is the CSMA CA. So, how does it work? So, first we will see that this is the flow chart, this is the start, set back off time to 0, then persistent strategy is there. There are 3 different types of persistent strategies that we have already learned, that is P type persistent technology, then I type, and there is another type of so basically 3 types of persistent strategies are there. So, we have to use one of it, then wait for the DIFS for some time, then send the request to send. RTS means request to send command has been set up, then set a timer, then CTS, that is clear to send received before timeout. If it is not, then it has to increment the back off, and if it has received, then wait for another SIFS time, send the frame, set a timer, acknowledgement is received or not. If it is received, then yes, it is successfully received at the receiver side. If the acknowledgement has not received, then the increment will be back off. So, this is what we have set to 0, it has back off limit is there. So, we have to just set up the limit for how many times you can back off. So, this is the case for back off condition, then it can be either aborted or you can wait for the back off time. So, this is the case, this flow chart is basically described, has basically described that what is CSMA CA, that is the carrier sense multiple access collision avoidance, which means more than one user are going to use a common channel. Then in any of the case, there is a condition which may occur that collision will take place and it has to be avoided. So, this is the case for carrier sense multiple access collision avoidance. Now, next is this is showing that between the source and the destination, how the data will be transmitted or how it will be received. So, there is a command which has been written over here, RTS and CTS. RTS means request to send, CTS means clear to send. So, in both the cases it has clearly mentioned. So, the previous flow chart is been shown by this diagram only. This is DIFS time and this is SIFS time. So, when it the source is waiting for the DIFS time for this time duration, after ending of this DIFS time, it will send a command, that is request to send. Then after this SIFS waiting time, it will going to send the clear to send command to this source again. Then for again waiting for the SIFS time, it will going to send the actual data that has to be transmitted when there the connection has been set up between the transmitter and the receiver, and then it will going to for again waiting for this SIFS time, it will going to send the acknowledgement. This acknowledgement most of the time it is positive acknowledgement, and if it is a negative acknowledgement, then it will going to be written like an AK. So, that is the case for negative acknowledgement. So, any of the cases you can consider either the positive acknowledgement or the negative acknowledgement. Then this is between all other stations. So, this is the time, this is NAV, that is the no carrier sensing is there, that is denoted by this NAV. This is the time axis which has been written over here. So, this is the CSMA CA condition, that is the carrier sense multiple axis collision avoidance. So, in this case you can see over here that there is no collision is there between the transmitter and receiver. The data is perfectly received with a positive acknowledgement. This is a positive acknowledgement. Why this happened? Because of the DIFS and the SIFS time. So, there is a time or timer has to be set up between the RTS and the CTS command. So, in that case, if we are not waiting for a specific point of time, then definitely the collision will take place. So, that is the advantage of using this DIFS and SIFS time. Now, this is diagram is showing the repetition interval. What is repetition interval? As you can see over here, this is the beacon frame is there. Now, what is beacon frame? Beacon frame is nothing, it is related to the antenna only. Then this is the contention free, CF means contention free, and this is the repetition interval. As you can see over here, this is NAV, these are the 3 time axes are there. This is access point, this is poled station, and these are the other stations. So, this is first PIFS time it has to wait, then another station will going to transmit the data, then again wait for the SIFS time, then it will going to poll with the using this poll station, it will going to poll the transmission. That it is basically what is polling? Polling means it is going to ask that whether you have data to send or not. If it is having the data, then the connection will be established and it will going to transmit the data. If it is there is no data is there, then it will going to definitely not going to transmit the data. Then an SIF time duration is there, then acknowledgement plus data will be transmitted. So, it is being transmitted from the receiver side, then it has wait again for the SIFS time. This is acknowledgement plus poll, and this is the CF end, and this is known as the contention duration. This is time axis. So, this is the repetition interval which has been described in this slide. Now, next we will move to what is frame format that has been considered for this MAC layer operation. So, in this frame format, as you can see that different versions are there, like this this 2 bytes, which means it is 16 bits of information. 1 byte is equals to 8 bits, then 16 bits of information. On these 16 bits are divided into these set of informations, like first 2 bits are used for the protocol version, what type of version has been used for the protocol, then what is the type of the particular frame that has been transmitted, then subtype it will consider what type of data or device has been transmitted, subtype, type, that there is subtype which is of 4 bits, then 2 DS, that is the destination, that is a data sequence. Then from DS it will going to receive more flags. If you want to enter any additional information, then more flags will be used in this case, that is of 1 bit of data. Then retry operation is there, power management, then more data if you want to enter, then WEP, and this is the reserve bit. Reserve bit most of the time it is used, or in any of the case you can reserve for the future purpose. If any additional information you want to transmit, you can transmit in this reserve bit, that is of 1 bit of information. Now, next it is using this data, that is the actual data you want to transmit, that is of 2 bytes. This is address 1 which is of 6 bytes, again address 2 again 6 bytes, address 3 of 6 bytes are there, 2 bytes of data is there for SC, address 4 is there which is of 6 bytes, then 0 2 2 3 1 2 bytes of data is being used for the frame body. Then FCS, that is the frame check sequence, which is the last flag that has been used, and this is basically used for when it is received, this frame is received at the receiver side, then frame check sequence will be checked, and it is being checked that whether there is any error or not. If there is not any error, then this particular frame will be received. If it is not having any, if there is any error, then it can be aborted also, or retransmission can also be performed in that case. Now, you can see in this table what it is showing. This is basically showing the explanation of the frames in a frame, in fields in a frame. Like this is the field, that is a version which is the current version which is 0, then type of information. If it is a management information, means the transmitter and receiver kind of management information it has sent, then 0 0 will has to be a type of data. Controlling information, then 0 1 will be used, and if it is data, then 1 0 will be used. Then subtype of each type of data will be shown in the next table. To DS, then from DS, then more flag, when set to 1 means more fragments are entered in this case. Retry, when set to 1 means retransmitted frame will be there. Power management means when set to 1. So, in all the cases, if you see, if a 1 bit is required, so either that 1 bit can be 1 or 0. 1 means true, 0 means false. This is the basic rule of digital, you know it. Then if it is 1, then power management will be there. If it is 0, then no power management. More data, when set to 1 means station has more data to send. WEP means wired equivalent privacy will be there, that is the encryption implementation, and RSVD means this is reserved bit. So, this is the case for particular frame that has been discussed over here. Now, next is the control frames. Control frames are nothing, this is RTS, that is request to send, CTS or acknowledgement means clear to send. So, in case of this RTS, you can see that 2 bytes of information, again that is of 16 bits is used for this FC. This is used for transmission of the actual data, this is used for the transmission of address 1 and address 2 respectively, and 4 bytes are used for the frame check sequence condition. In case of this CTS, as you can see that only one address is required, and which is the obviously for the transmitter side, there is no receiver address is required, and it can be used as an acknowledgement figure also. So, that is the case for control frame. Now, next is the values of subfields in the control frames. You can see this subtype, that is 1011 is used over here, 1100 and 1101. So, meaning is request to send if it is set to this point, clear to send is this one CTS, and this is acknowledgement is there if it is used as 1101. So, this is the values which is used in the subtype, which is of 4 bits of information. So, these are the references that you can go through for this particular topic, that is B.F. Frozen and Starling's book. So, in this lecture we have discussed about IEEE 802.11 standards and its different implementations, and then we have seen about CSMA CA concept, its flow chart, then how this information will be transmitted in between the transmitter and receiver, and its different frame formats. Thank you.